Okay, this is the Professor, CBMD PhD. This is Wednesday, October 25th, 2023. It is 2:41 and 31 seconds, AM Eastern Standard Time. And today's research, quantum light. So let's jump to it here. How quantum light sees quantum sound. Date October 24th, 2023. Source, University of East Anglia. Researchers have proposed a new way of using quantum light to see quantum sound. A new theory reveals the quantum mechanical interplay between vibrations and particles of light, known as photons, in molecules. It is hoped that the discovery may help scientists better understand the interactions between light and matter on molecular scales that potentially paves the way for addressing fundamental questions about the importance of quantum effects and applications ranging from new quantum technologies to biological systems. There is a long-standing controversy in chemical physics about the nature of processes where energy from particles of light is transferred within molecules. Are they fundamentally quantum mechanical or classical? Molecules are complex and messy systems, constantly vibrating. How do these vibrations affect any quantum mechanical processes in the molecule? As these processes are typically investigated using techniques that rely on polarization, the same property of light used in sunglasses to reduce reflections, but this is a classical phenomenon. As these techniques from quantum optics, the field of physics that studies the quantum nature of light and its interactions with matter on the atomic scale, can offer a way to investigate genuine quantum effects directly in molecular systems. Quantum behavior can be revealed by studying correlations in the emitted light from the molecule placed in a laser field. Correlations answer the question how likely it is that two photons are emitted very close together and can be measured using standard techniques. But research shows that when a molecule exchanges photons, quantum mechanical particles, of sound with its environment, this produces a recognizable signal in the photon correlations. While photons are routinely created and measured in laboratories all over the world, individual quanta of vibrations, which are the corresponding particles of sound, photons, cannot in general be similarly measured. The new findings provide a toolbox for investigating the world of quantum sound in molecules. They have also computed correlations between photon and photons. It would be very exciting if the research could inspire the development of new experimental techniques to detect individual photons directly. And this is the Professor of Space Technology, Advanced Physics, Mathematics, Computer Science, and Leader of Research. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have an awesome day.